So again, welcome everyone to this Open NLP Meetup tonight. I'm very happy that we have two top-notch developer advocates tonight who will present about hybrid retrieval with Haystack and with OpenSearch. My name is Yücel. I'm just moderating this event tonight, and I can briefly explain how this is going to work. So we'll start with a presentation. It's a joint presentation by the both speakers, lasting about 35 minutes. You can still use the chat during this presentation to ask questions. And me and also another colleague will try to maybe also answer some questions live in the chat. And then after the presentation, we will have time for Q&A, live Q&A. Again, you can write your message in the chat, and then we can read out the questions loud. The meeting is also being recorded, and we will upload the recording later on to YouTube. And then after the Q&A, we will turn off the recording and we will have some Zoom breakout rooms to have some discussions in smaller rounds and smaller groups, making use of this Zoom feature. And before I talk too much, I think I can hand it over to the speakers now. So thanks, Bilge and David, for being the speakers tonight. The stage is yours.
Thank you, Julian, for this welcome. Hello, everyone, and thank you all for joining from different parts of the world. Today we'll talk about hybrid retrieval and how to use hybrid retrieval in RAG pipelines with Haystack and OpenSearch. Let's start with a brief introduction. My name is Bilge. I work as a developer advocate at Tippett for over a year now. I live in Istanbul, Turkey, and on social media, I share content on Twitter and on LinkedIn about NLP world, how to build stuff with Haystack, and the things that I build, I put their code on GitHub so that you can also share and try it yourself. And David.
Yeah. Hi, everyone. My name's David. I'm a senior developer advocate, and I work on open source OpenSearch at AWS. So it's a little fun because my background isn't actually search or search engineering, natural language. I am so out of my water here. I only just got started in the space about 2 years ago when I moved into OpenSearch. I was doing DevOps before and all of these other things, but yeah, super happy to be here, talk to you about retrieval, and yeah, happy that Bilge was welcoming to include me on her talk.
Nice to have you. So this is going to be today's agenda. We'll talk about search applications and retrieval, and then we'll mention two search approaches, keyword-based and semantic search. We'll combine them with hybrid retrieval and show you how to create an application with hybrid retrieval using Haystack and OpenSearch. Then we'll see how we can use hybrid retrieval for RAG pipelines or RAG pipelines. And then at the end, we'll accept and we'll be answering your questions. So let's start. Imagine you have a bunch of data. It can be your documents in your OpenSearch, but it can be also like Slack messages, emails, or like websites you can crawl from the internet. And you want to do some sort of search from it. So you want to extract some information. You might be trying to build a document search application by finding the right documents, or you might be trying to answer questions from these data. It can be in an extractive form or a generative form. And for all of these search applications, you need retrieval. Retrieval is the idea of getting the right documents from your database. And we will be using these search and retrieval terms interchangeably in this presentation, so you can think them as a very close concepts. And by retrieving documents from your database, you can also be doing some sort of filtering, and you will be then using these filtered documents for further applications, such as building your question answering system. But you need to retrieve these information, so you need to filter out this information from your database, because when you want to build something further, extractive question answering systems, the models you will be using to extract the answer, they are pretty slow. And if you just feed in all of your documents, the inference takes a really long time for them. So you might you might want to make the life easier for them and give them less but more relevant documents. And also, if you are working with LLMs, you might have noticed that they have a limited context window, so you cannot fit in all of your documents into your prompt. That's why you would only want the relevant part of your database, which is what you can also which you can get with document retrieval. And when you think about building a document retrieval pipeline or document retrieval applications, you might need some tools, and this is where Haystack comes into play. Haystack is a fully open source framework built in Python for custom LLM applications. It provides the tools that developers might need to build state-of-the-art NLP systems. And in Haystack, there are two building blocks: pipelines and components. Components are the smallest units, and these components can do one task in the best way. And by connecting these components, you can form more complex systems, and we call them pipelines. Let's see an example of an NLP system built in Haystack. So as you can see, there are like two pipelines and one document store in the middle. I'll go one by one, so you just follow the arrow, and I'll guide you through this diagram. So the backbone of any NLP application is the document store. Document store is where you store all of your data. And for example, you can choose OpenSearch and store your data in OpenSearch. And in order to do that, you might need an indexing pipeline, because you have your documents, but maybe you want to pre-process them, maybe you want to convert them in some other format, or you might be also willing to add embeddings. And this is why you would be using this indexing pipeline. And the other step is query pipeline. This is where you or your users might be interacting with the data you put in the document store. And this is also the place where you would use the large language models from Hugging Face, OpenAI, Cohere, or any other model you deploy yourself.
Yep. So actually, can I have you click one more time? I, of course, put this. There we go. This is the first bit. So what is OpenSearch in this case? I just saw the question come through. Is a document store and a vector database the same? And some document stores are just vector databases. Some document stores are just BM25, we'll say retrieval systems. OpenSearch does both. So what is OpenSearch? OpenSearch is an open source search engine, we'll say. And what it does is once you take your documents, you use those preprocessors, right, to get all of your information out. It ingests it into all of these different indices that allow you to search. So this is a kind of example of what an OpenSearch cluster might look like. We have data that comes in to a coordinating node, and that coordinating node will look at the index that data is going into and route it to the appropriate underlying nodes that it's learned from the cluster manager. So because OpenSearch is open source, you can go and download, set this up for yourself today. It's Apache 2 licensed, and yeah, what OpenSearch does at its core is it distributes the work of searching through documents across multiple different nodes. So, right, if we use grep, we can search through things fairly quickly on a single system. But once you start getting into multiple systems and once you start doing relevance and scoring, that's where OpenSearch really comes into play. Can we flip to the next one, please? There we go. So we've got our friendly user here. This is OpenSearch Man. And OpenSearch Man is looking for some data. So one of the ways that a lot of people interact with OpenSearch is actually with OpenSearch dashboards. And dashboards just provides you an interface to do analytics on your data if you're in the observability space. We have a search comparison tool that allows you to compare the results of two searches side by side. And a lot of other tools that can help you fine-tune your search before you get it into production. Can we hit the next slide? So OpenSearch is community-driven. So it's actually really important. If you guys find something and you're like, hey, this isn't working, open an issue, create a pull request. we're constantly looking for feedback on OpenSearch. OpenSearch has 320 million downloads. That's as of a month ago. That number keeps changing so quickly that I'm like having to redo my slides constantly. We've merged 22,700 pull requests just in the last 1 year. And we have over 500 contributors. And these contributors come from all different places with all different needs. But the one thing they have in common is they want OpenSearch to work well for them, which is why they contribute. So please, yeah, feel free to contribute. And with that, can we go to the next slide? So we know that OpenSearch is a document store. It can do vector retrieval. It can do BM25 retrieval, which we'll talk a little bit more about that in just a minute. But one of the things that might help you decide which type of retrieval you should use is what kind of data do you have? And how do you plan on querying your data? Are people searching? A lot of times when people do searches, they look for keywords. And those keywords could be, say, for example, just individual tokens that they're looking for in a document. Or are they using whole sentences? Are they asking questions of your data? In that case, you're going to be looking at something like semantic search. So semantic search takes and breaks down sentences into their meanings and allows you to query based off of that meaning. Can we go to the next one? So here's kind of a great example of where keyword search might fail you, where semantic search might do better. So with keyword search, right, if we're looking up, say, Wild West in a document store, BM25, or lexical token-based search, is just going to look for the instances of that word in the document. It's going to count how many instances that has. It's going to see how many other documents have that word or do not have that word. And it's going to calculate some relevance based off of that. This fails to take into consideration the context here. So semantic search, on the other hand, looks at Wild West and it says, hey, I recognize that these two words, their distance from each other is important. Because they're close, we're looking for Wild West as in the concept, not the words wild and west, which is what keyword-based search would look for. So again, in our semantic search, we've got cowboys, hats. We recognize like that is Wild West versus a wild animal, and West Virginia University probably was not what we were looking for in this case. Can we hit the next slide? So here's kind of the two different retrieval methods side by side. So on the keyword-based retrievals, we have BM25, which is OpenSearch's default. And that stands for Best Match 25, and it's the 25th iteration of the Best Match algorithm. And like I said, it's just a straightforward algorithm on like how many times that word appears, how many other documents that word appears in, and it's trying to find that very quickly. And it is a very fast retrieval mechanism. Then, on the other hand, we have our semantic retrieval. This uses dense embeddings, which is just an array of these floating point numbers like we can see at the bottom. These generally mean like, or encapsulate the meaning of our sentence. So, and this is done with trained models, with OpenAI, Cohere, sentence transformers. They produce these embeddings, and they are used to see if two sentences are semantically similar. One of the challenges with semantic retrieval, though, is it is a very heavy, heavy workload. So for example, KNN, it's looking for exact matches across all the documents in your index, which can be very time consuming. Also, I'm going to hit the question that just came up in the chat. OpenSearch vector search does differ from Elasticsearch. So Elasticsearch is only using Lucene as a vector store. The challenges with that are Lucene's vector store has a very limited dimensionality, which can't encapsulate every model. So dimensions are just the number of items in an array, that embedding array. So OpenSearch supports Lucene's vector store, FICE, NMSlib. So you can kind of pick which vector store has the features you're looking for, whether if you need pre-filtering, you might pick something like FICE, Or if you're looking for very quick updates, you might look at something like Lucene. But yeah, so they're fairly different, I'll say. Can we hit the next one?
Yeah. Thank you.
Yeah.
And to compare these two retrieval methods, or like search methods, we can say, we define two different search examples for you, and we use the Haystack tutorials as our data set. So in Haystack, we have some tutorials. They are all markdown files, and we want to build a search system for them. Let's imagine. And our user comes, and this is where we use the keyword-based search. Our user comes and asks, like, creating an agent with memory. If we use keyword search, our search application is not capable of finding a matching result for this query, because it tries to find a document, a part of the document where it contains all the words in the query, which is apparently doesn't exist. But if we use a semantic search application for our application, when we enter this query, it can understand that it's about like agents and memory, and it's about creating something, so it can easily find the relevant part among our documents. And let's think the other way around. Let's imagine like the user comes and asks retrieval augmentation. Keyword-based search can easily match this term with the terms that we already have, with the words that we already have in our documents, and can return us some meaningful results. And actually, they are the most relevant results that we have in our documents. But when we check the semantic search application, retrieval augmentation doesn't really, the retrieval augmentation is not really in the training data of the semantic search application, or the embedding model that we use for the semantic search application. It's a fairly new concept, but our semantic search is kind of clever and makes it similar to the data augmentation, and it returns results about data augmentation here. I mean, it's better than nothing, but still it's not the most relevant result, and not the result that we desire for. So imagine you have these tutorials and you tested like 2 approaches, but like none of them works the best. So what would you do if you want a better performance? You can train your own embedding model for the semantic search. So you can introduce this retrieval augmentation term to your model. But to train a model, you need to collect data. You need to train your model. And these all, like, you need some sources, and you need some time, and you need some effort. And also, if there is another term coming tomorrow, you need to retrain your model to teach this new term to your model. As the other solution, you can try hybrid retrieval. And what is hybrid retrieval? Hybrid retrieval is the idea of combining these 2 approaches. Here in the first line, you see the BM25 retriever, which retrieves the data depending on the keyword match. And the other component, the other pipeline, is for semantic search. It's using an embedding model to understand the semantic similarity between the query and the document. And this hybrid retrieval approach is actually what we used in the tutorial search application that we have in our website. And in the next slides, I'll explain the details of how we built this system using Haystack and OpenSearch. So imagine I mentioned about indexing pipelines. It's the pipelines that you would use to put your data into your document store. So we have tutorials on the left-hand side, and they're all in Markdown forms. We use our Markdown converter component to convert all of them to Haystack documents. Then we pre-process them, make them smaller, maybe remove some unnecessary spaces, and then we embed them. So we create dense embeddings for each of them, and then we put them into our OpenSearch document store. And this is how the how this pipeline looks like in code, we have our OpenSearch document store, Markdown converter, preprocessor, and embedding retriever initialized one by one. And in the embedding retriever, you can see that it's the sentence transformers models that we are using. You are free to choose any other open source model on Hugging Face, or you can try OpenAI or Cohere embedding models if you want to use them. And we add them one by one to our pipeline. And when we run this pipeline with the tutorials that we want to index, they all go through this pipeline and gets indexed to the OpenSearch document store. So this was the indexing pipeline. And let's see how the hybrid retrieval pipeline looks like. So here on the left-hand side, we have our document store where we store all of our documents with the indexing pipeline. And we have two retrievers, embedding retriever and BM25 retriever. Embedding retriever retrieves some documents, again, based on the semantic similarity, and BM25 retriever retrieves data based on the keyword match. And they both return some documents. They can be some common documents, they can be completely separate documents. And in the join documents node, we join these documents. And there are three options that you can choose here. You can either concatenate all of these documents you retrieved from different retrievers. You can merge them by giving one of the retrievers more weight, so you give more priority to the documents that you retrieve from one of the retrievers. Or you can use reciprocal rank fusion, which is basically depends on the ranking of the documents, documents from each retriever, and it's another algorithm. But for this one, we use concatenation because we would be using a ranker after joint documents. And here, this ranker ranks all of these documents that comes from the joint documents by checking the relevancy of each document with the query. So as you can see, in the order of the joint documents and the resulting documents are different than each other. And this is how we would be creating this pipeline with Haystack. Again, we create these components one by one. We have our BM25 retriever, and you can see it has a custom query parameter there. This is very open source specific one, and I'll talk about it in the following slides. We are again using an embedded retriever, and we are using the same model. Here, you can also use the same embedding retriever. We are joining these documents with the concatenation, and in the last, we are using a ranker, which is using a cross-encoder model to find the relevancy of each document with the query. And again, we are adding these nodes, adding these components to our pipeline, and when we run the query, our pipeline is now capable of returning the most relevant results based on both keyword-based approach and semantic approach. So let's take a closer look at this custom query that BM25 has. This is very open source specific. Here we use three fields, fuzziness, and operator. Fields is the parameter that you want to share with OpenSearch so that OpenSearch can make this keyword-based match. Here we only wanted our content to be searched. So we initialize content here, but you can also pass the title of your documents or any meta information you would find useful. Fuzziness is a very helpful one, I would say. It's the number of character operations to prevent typos. And if you select auto here, OpenSearch is capable of optimizing this process for you. So you don't need to think about how many operations you would accept for users to make to prevent typos. And the operator is the last one. Here we chose the AND operator, which means that I want my BM25 retriever to return results if every word in my query can be found in my document. So let's stop here and recap what we have talked about. So we talked about search applications and retrieval. We talked about keyword-based and semantic search-based approaches. We talked about hybrid retrieval and how to create a hybrid retrieval pipeline with Haystack and OpenSearch. Now I'll continue with hybrid retrieval for RAG pipelines. So RAG is actually an acronym for Retrieval Augmented Generation. And to understand what RAG is, we need to understand how LLMs work. LLMs are pretty capable models. Like they can do text generation, they can do generative question answering, they can even write code for you. But they also have some sort of limitations. And I think, in my opinion, the biggest limitation of large language models is their knowledge is limited. Like they had a training data collected a couple of years ago, and once they were trained with that data, they only have this knowledge till that certain point in the time. So when I ask a question about like current events like this talk to a large language model, for example, here in this ChatGPT, what time is the talk? I mean, from hybrid retrieval to RAG, and it answers as, I'm sorry for any confusion, but I don't have access to real-time or future event schedule. So it doesn't know when this event is. So it's not able to answer this question. But we can solve this problem with retrieval augmented generation. This is basically adding context to the prompt, so adding more information to the prompt so that large language model can answer this question. And here I copy pasted the content that I found on our Meetup page. And I asked the same question again to the large language model. And now ChatGPT can say like, this talk is scheduled for 6 p.m. Central European time, as indicated in the provided context. So the idea of augmenting context that we generated to the prompt is called retrieval augmented generation. And this is also how this retrieval augmented generation pipeline looks like with hybrid retrieval. You should be familiar with this part of the pipeline. This is hybrid retrieval that we've talked about before by combining these two retrievers. And the additional thing we do for RAG pipeline is adding this prompt node. Prompt node is the connection node to the LLMs. It receives input from different components. For example, it can receive documents from join documents component, and it can receive the query from the user. It generates the prompt and then sends this prompt to the large language model. Large language model process that prompt, and then prompt node returns the response as the answer. And this is how we initialize the prompt node and the prompt. Here you see the prompt template. It's the same prompt that I used for the ChatGPT example. Basically here we have the context, and we have also a join documents variable here. Then this variable will then be replaced with the documents that prompt node received from join documents node. And the question part will be filled by the user query. We pass this prompt to prompt node, and as the model we define GPT 3.5 Turbo, which is ChatGPT, but of course you can use any other large language model here with this prompt node. And then we add the prompt node to our hybrid retrieval pipeline. Now it becomes a hybrid retrieval with RAG pipeline, and then we can run this pipeline and use it with our query.
So yeah, that was a phenomenal example of how this is really being used at the moment to improve search and relevance on Haystack's own tutorial search. And if you want to see kind of a similar type system, I'll say production type system, but make sure to check this out. So this is an example that OpenSearch did with Haystack, where we took OpenSearch's documentation, ingested it using Haystack's ingestion pipeline, and then use that alongside with OpenSearch and a model hosted on SageMaker to encapsulate this entire process and host it entirely within your, we'll say within your control zone. So this is no longer using external models, right? This is a controlled by and deployed by you system. So definitely make sure to check this out. And there's a lot on OpenSearch's roadmap. I just want to point out, like, we've been building and growing really quickly, especially in the areas of machine learning and natural language processing. So great example, in our 2.9 release, we had pre-filtering with FICE. We added that in. We added ML connectors that allow you to interface with external ML models in OpenSearch to allow that ingestion pipeline to go a little bit smoother. We've added conversational memory, RAG pipelines, hybrid search operators, and in 2.11, we just released, I put multi, hold on, is that that's supposed to be multimodal search, and my brain cannot process if that says multimodal or multimodal, so it should be multimodal search. We also have default models for neural search, model statistics APIs. We've just enabled sparse retrieval, which is another ML type retrieval that performs with a speed closer to BM25. So there's a lot getting released on OpenSearch's roadmap. So make sure to check that out and plug in. And I'll put a link down to the roadmap in the chat.
And as a last slide, I'd like to also share some information about Haystack. We have a community on Discord. Now it's over 2,000 members. So you can scan the first QR code to join our Discord community. We have a Twitter account, and in this account we share like releases, we share the new tutorials, demos, or interesting PRs. We also share announcements about events like this one. So go and follow us. And as the last one, we are now implementing a new version of Haystack 2.0, and some of the components are already implemented. So you can scan this code, check our announcement, what's going on with Haystack 2.0, and maybe even start building small applications with 2.0 components. And my name was Bilge. I am pretty active on Twitter and on LinkedIn, so you can also follow me in these social media platforms. Thank you for again joining, and I think now we can start answering your questions.
Yeah, thanks to you. Thank you to our speakers. So let's see whether there are any questions in the chat already. We answered a couple of them already live, but to all the attendees, feel free to share more questions in the chat for Bilge and David.
I saw one come through, Bilge, that I thought you might want to answer, which is which ranker were you using in your demo? Someone was asking about that.
Yeah, maybe I can go back to that part. So yeah, it's sentence transformers ranker. I'm not sure if you can see my cursor here, but it's sentence transformers ranker with the cross-encoder model. This one, I mean, it has a pretty long one, and it's an open source one, but there are also different rankers. Maybe I can also share that bonus slide with you. So yeah, we use the sentence transformers ranker because we wanted to rank by the relevancy, but you can of course try different rankers that are available on Haystack, such as diversity ranker, lost in the middle ranker, recentness ranker, or you can use a ranker model from Cohere with the Cohere ranker component. I hope that was the question.
There was a question also maybe related to this slide about the join document function and what it does, what other options there might be, what other options are available. Yeah.
Yeah, so there are three. Can you see my slide? Yes, I guess. So there are three options here. Merge, concatenate, or reciprocal rank fusion. So concatenate is pretty straightforward. You just concatenate the retrieved documents from two retrievers. The other one is merge. You basically define a parameter and you say like, okay, I want to prioritize the documents coming from embedding retriever, so give them more priority and some sort of rank them. I mean, this doesn't really make sense in the hybrid retrieval approach, but it might be useful if you are, I don't know, like retrieving data from different sources. For example, one of the retrievers is connected to your Slack messages and the other one is connected to your, I don't know, emails, and you want to prioritize the data coming from Slack messages. So this might be the option you want to try in joint documents node. And the last one is reciprocal rank fusion, which is basically prioritizing one of the documents depending on their order coming from the retrievers. For example, if you want to check this one, okay, for example, D was returned as the first document here, and it was returned by the fourth. So as we join these documents with the reciprocal rank fusion, it will be ranked by this. Whereas A was returned as the first one, and here it was returned as the third one. So probably A will be in the higher rank than D. And so in a high level form, I can explain reciprocal rank fusion like this. But if you're planning to use a ranker component after joint documents, maybe it doesn't really make sense to use merge or reciprocal rank fusion, because you would be, again, ranking these documents again, so you don't need to do any other ranking here.
There was another question about the language models, in particular open source large language models, and whether you can recommend any that are small but still give good results.
I mean, this model, or I think there was another one. I can't remember the name right now, but the sentence transformers are really good if you are just starting to try these embedding models. They are open source and you can use them through Hugging Face, and they perform pretty good actually. If you're not like using medical data, or if you are not working in finance area, for example, they are pretty good. But of course, you need to try and test how these models perform if you have a domain-specific data, or you can try hybrid retrieval, of course.
Couple of more questions in the chat, and I think we still have time to answer some more.
Yeah.
There's a question about the connection between knowledge graphs and document stores, if you want to say something about that.
Yeah, they are quite different. So you need to train, I mean, they have different dynamics. For document stores, you store your document and you store your embeddings. Whereas in a knowledge graph, you store, like, I am not very sure about the terms here, but you need to train your own model so that your model can understand how to put every new information to the knowledge graph. So I would say that they are pretty different concepts.
Yeah, I can also jump in here. Exactly. I would say in the knowledge graphs, you usually store your knowledge in a structured way. Sometimes you have triples of subject, predicate, object, right? So triples. And then you have query languages to find these triples and combine them to statements that answer your questions. And in contrast, the document stores we deal with, they store unstructured data. just like plain text data. So it's not really structured knowledge that you have. You could say that both are kinds of knowledge bases, but that's the main difference, I'd say. And one you have unstructured, and then the other structured knowledge. There's one more question. How difficult, easy is it to connect internally hosted models to the prompt node, like a custom API endpoint with their own URL and API? So if you're hosting a large language model internally, could you use that as a prompt node?
It depends on what you mean by like having like deploying large language model internally. For example, if you are using, maybe I can go back to that slide here. Not this one, yeah. If you have your model in Amazon SageMaker, yeah, you can use this model. And if you, for example, if you have your large language model in Azure, you can again use this prompt node. But you can also use the local, you use large language models locally, but not through the API.
Yeah, we have a couple of invocation layers, we call them in Haystack, in the current version of Haystack. And you can, depending on how exactly you host your model and whether it aligns with, I don't know, the Hugging Face endpoint API, for example.
Yeah.
You can also host these models then locally. And there are other invocation layers, also contributions from the community. So chances are pretty high that if you're hosting your large language model, somebody else in the community is doing the same, and they've already implemented then the matching invocation layer. So let me go through the chat again to see whether I missed any question. What strategies do you typically use if a prompt is too big? For example, if the joint documents retrieved by the two approaches are bigger than the context size of the large language model. How do you reduce the size so that it fits the prompt, but you don't lose important information?
Oh, there are different approaches. On the top of my, I mean, if the prompt is longer than the context window size because of the context, so maybe let me go back to that slide. Okay, so here, for example, this is the prompt template that I used, and if the prompt is long because you put too much documents here, you can like try to limit that size. You can maybe use different rankers to increase the knowledge here. So increase the different knowledges here. Actually, I had an example for that. Let me maybe, share that. So for example, you retrieve some of the documents with hybrid retrieval, or it doesn't really matter which method you are using. But like you cannot fit all of the retrieved documents into the context window of the large language model. So what would you do? You can either like say the retrieval, okay, like I cannot fit in like this 8 documents or 10 documents, maybe just give me like 5. Yeah, that's a solution, but it will also mean that you will be using some of the information that are available here in the red documents. But instead, you can retrieve all of these documents, and then you can use a diversity ranker, which would be like getting all the diverse documents. And instead of like using one blue and the other shade of blue, you can just pick one blue in your context window, and then you would not be missing much information, but you would be also increasing the diversity in the context so that the large language model can still be answering the question without like missing some important information. This can be one of the approach using the diversity ranker.
Right, thanks. And I think we answered all the questions that I was able to see in the chat. And I would suggest that we stop the recording then here, and we can jump into the breakout rooms for whoever wants to stick around and discuss some smaller rounds. So yeah, thanks again for joining this Meetup event tonight. Thank you to our speakers again. And then
Thank you.
hope to see you next time. And I'll open the break rooms now.